All right, so let's talk about blockchain. I know, you hear that word and your brain might just switch off. All that talk about crypto and code. But what if I told you it's not really about complex tech at all? Seriously. If you strip it all away, blockchain is actually a super clever answer to a really, really old human problem. How in the world do we trust each other?
I mean, just think about it for a second. You do this all the time. You're scrolling online, you find that perfect thing you've been looking for, but the seller is a total stranger, maybe on the other side of the planet. How do you trust them with your money? How do you know for sure you're going to get what you paid for, and they know they're going to get paid? Well, for a long time, we really only had one way of solving this.
Yeah, we rely on a middleman, right? A company like PayPal or Alipay, some big name we trust. You send them the money, and they kind of hold it in this digital waiting room. Then they ping the seller and say, hey, we've got the cash, you're good to ship. Once the package arrives at your door and you say, yep, it's all good, then they release the money to the seller. It's a system that works for sure, but notice the key here. Your trust isn't in the seller, it's all piled on that one single company in the middle.
But that puts all our eggs in one basket, doesn't it? It creates this one giant single point of failure. I mean, what if that company gets hacked? What if their servers go down? Or heck, what if a meteor just happens to land on their data center? It sounds dramatic, but if that central record disappears, so does your money, your proof of purchase, everything. It could all just, poof, vanish. And that vulnerability, that single point of failure, is the exact problem blockchain was invented to solve.
Okay, so how does it solve it? To really get it, we're going to use a super simple analogy. Let's just forget about computers, forget about code, and instead let's imagine a tiny little city. Now, this little city is special. There are no banks, no PayPal, no big companies in charge of the money, nothing. It's just a bunch of people who need to buy and sell stuff from each other. So how do they possibly do that without a middleman to trust? Well, it turns out to be shockingly simple. They just make it public. Every single time a transaction happens, like if person A wants to give person B one coin, they don't do it quietly. Nope, they go right to the center of town and they shout it out loud for everyone to hear. And this is where the magic happens. Everybody in town hears that announcement, and what do? They each pull out their own little notebook, their own personal ledger, and they all write down the exact same thing. Okay, A just gave B one coin. Now think about what that means. Every single person in the city has their own identical, constantly updated copy of every single transaction that's ever taken place. Not one central book, but hundreds of them. And that right there is the fundamental difference. You see, in the old system, one company has the one master copy of the records. If that's gone, everything's gone. But in our little city, everyone has the master copy. If you wanted to cheat the system and erase a transaction, you wouldn't just have to change one book. You'd have to sneak into every single person's house and change their notebook without anyone noticing. It's practically impossible. The trust is no longer in a company. It's baked into the system itself. It's distributed. Okay, I know what you're thinking. That's a great idea, but what's to stop someone from just lying? What's to stop person A from going back later and trying to erase that entry from their own book, or trying to change a 1 to a 2? How do you protect the past? Well, this is where we get to the chain part of blockchain. See, having hundreds of notebooks is a great start, but to make it truly bulletproof, the city needs a way to lock in the past, to make those written pages permanent and unchangeable. They need to forge an unbreakable chain. Here's how they do it. Imagine that once a page in everyone's notebook gets filled up with transactions, the whole town agrees, okay, this page is done. They take that completed page and they decide to seal it away, starting fresh on a new one. That finished, sealed up page of transactions, that's a block. It's basically a permanent snapshot in time. So how do you seal a page? This is the really cool part. They use something that's basically digital magic. It's called a hash. You can think of it like a super-powered fingerprint scanner for data. It takes everything on that page, every single letter, every number, every comma, and it crunches it all down into one totally unique, unbreakable digital fingerprint. It's a seal that is unique only to the exact contents of that page. And the power of this seal is just incredible. Look at this. If you try to change anything on that page, I mean anything, even just changing 1 coin to 2 coins or adding a period, the fingerprint, that hash, doesn't just change a little bit. It changes completely. It becomes a totally different, unrecognizable code. So if some sneaky person tries to go back and alter a past record in their own notebook, their page's fingerprint won't match anyone else's.
The fraud is spotted instantly by the entire community. Game over. And then they add one more layer of security, and this is what creates the chain. When they seal a new page, say page 10, they don't just put a fingerprint of page 10's data on it, they also include the unique fingerprint from page 9. So page 10 is cryptographically chained to page 9, and page 9 is chained to page 8, and so on, all the way back to the very beginning. Now, if you try to change something way back on page 3, you don't just break the seal on page 3, you cause a massive chain reaction, breaking the seals on pages 4, 5, 6, all the way to the present. The entire chain falls apart, and everyone sees it immediately.
So let's put it all together. You take the idea of everyone having their own copy of the notebook, that's the decentralized ledger, and you add this system of unbreakable, interconnected seals. That's the chain of blocks. When you combine those two things, well, you've just built a trust machine.
This machine, this system, really has 4 key ingredients. First, it's decentralized. No one person is in charge, so there's no single point of failure. Second, it's trustless. And that sounds weird, but it just means you don't have to trust any single person. You trust the system. You trust the math. Third, it's collectively maintained. Everyone works together to keep it honest. And finally, all this creates an unbelievably reliable database. It's open for everyone to see, and it's basically impossible to change secretly. And that's why this whole idea is so profound. It's why, as The Economist famously put it, blockchain is a machine for creating trust. It's literally a system designed to manufacture trust, not with promises from a CEO or a government, but with cold, hard, transparent math. Which, of course, brings us to the final mind-bending question. Our little city was just trading coins, right? But this trust machine can be used to securely record anything of value. Think about it. Property titles, voting records, your own medical history, creative copyrights, the list goes on and on. So the real takeaway here isn't about digital money. It's about this. If we now have a tool that can create trust between strangers without any middleman, what else can we do with it? What parts of our society, currently built on trusting fallible institutions, could we completely redesign from the ground up?